Hi, and welcome to the video for 5-2, Day 2, Lesson 2. From our textbook, we have a bell ringer or warm-up here to go through. It says Maxine compiled a list of these car prices. $7,500, $6,500, $5,750, $4,900, $6,250, and $4,200. Find the mean of the prices in the media, and then answer the question, is the data skewed? Well, to do this, we have to put them in order. We're going to put them in ascending order, lowest to highest. So it looks like the lowest is going to be, whoopsie, shouldn't be doing that. Looks like the lowest is going to be 42,000, or 4,200, excuse me, 4,200. And then it looks like the next lowest would be 4,900. And then it looks like 5,750. Sometimes this is hit or miss. Sometimes you make a mistake and you got to go back, but you got to do it. And then it looks like it's, 6,250. And then 6,500. And finally, 7,500. So to find the mean or the average, we add all these together. And if you add 4,200, 4,900, 5,750, 6,250, 6,500, and 7,500, you come up with $35,100, and you divide that by 6, and you get 5,850 as an average or a mean. Now, to find the median, we have to get the middle number. We have a total of 6 numbers, so that means there's actually 2 middle numbers, and as we well know, to find the median for these 2 numbers, we have to add them together and divide by 2. So that would be 5,750 plus 6,250. That's 12,000, which when you divide by 2, of course, is 6,000. And this is the median. Now, they're not exactly the same, but they're pretty close. So I would say the data is not skewed. You got to be careful. There's a $150 difference, but all in all, I would say the data is not skewed. All right. Let's take a look at our last notes. That would be day 1 from 5-2, buying or selling your car. And write a question in the left-hand column. Question I put down here as an example is, what is the median? And the answer to that is it's the middle number of any series that are in order. And that's something you need to remember. You need to put them in order, because if you just take the numbers as they give them to you and you pick out the middle one, well, you're probably going to be wrong, because they're usually jumbled up. You may use this question or another question you think is more appropriate, and then write that down in your notes from our last time. Circle your 24, and hopefully your 10 is already circled. You can stop the video, complete this, and then hit play again when you're ready to proceed. Please title the next page of your notebook as follows: 5-2, buy or sell your car, day 2. This lesson was given on the 14th of the 15th of 2021, and our learning target is the same as it was on Tuesday and Wednesday, which is we will be able to compute the mean, median, mode, range, quartiles, and interquartile range. What that means is we're going to have some more of our definitions that are sprinkled throughout the chapter in this one. Get this down in your notebook, and when you're ready to proceed, hit play. All right, here's example 5, which is on page 227, and it's got quite a bit of the definitions I was talking about. It says, find the quartiles for the tire pressures of cars at an auto clinic. And they have 15, 17, 21, 25, 31, 32, 32, 32, and 34. Tire pressure is measured in PSI, pounds per square inch. And here's our definitions. It says Q1 is the first quartile or the lower quartile, and 25% of the numbers of the data set are in that. Q2 is the second one, and half the numbers are below Q2 and half are above. So it's basically the median. Q3 is the third quartile or the upper quartile, and it's 75% of the numbers are at or below Q3. And Q4 is the maximum value in the data set. Subscripts are these little numbers they put down below to name each quartile. The first thing you need to do when you're doing quartiles is to find the median, or Q2. And if we do that, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, so right here is our middle number. And now, from 31, we're going to determine what the lower quartile is and the upper quartile is. So again, I had to switch because I wanted to get those definitions to you, but I also wanted to be have enough space to show you how to work this. Now, for Q1, that means it's going to be right in the middle of these four numbers. It's right here. So it's kind of like the medians where we got two numbers. I have to go 17 plus 21, which is 38. And then I divide it by 2. And Q1 would equal 19. Over here, Q3, well, they're both 32. So it means Q3 is 32. You could add 32 and 32 together and divide by 2, but what you're going to come up with is 32. Q4 is the last number, so Q4 is 34. Get that down and we'll go to our next slide. All right, here's example 6, which starts on page 227. It says, what's the difference between Q1 and Q3 from number 5? If you recall, Q3 was 32. And we took Q1 away from it, minus 19. We get 13. This is what's known as the IQR, or the interquartile range. This is a good thing to know. The interquartile range gives us the range of the middle 50% of the numbers. A small interquartile range means the middle 50% of the numbers are clustered together. A large one means the middle 50% are more spread out. To find this range, you subtract Q1 from Q3. All right, here is example 7. It says, find the outliers for these tire prices. And they've been kind enough to put them in order for us. It's 45, 88, 109, 129, 146, 189, 202, 218, and 545. So remember, to find the outlier, we have to know what the interquartile range is, because we use a multiple of the interquartile range to see if any number is below or above what we call the outlier boundaries. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And that means that the fifth number is the Q2. So Q2, or the median, is 146. Q1 is going to be a combo of 109 plus 88 divided by 2. And 109 plus 88 is divided by 2, total and then divided by 2 is 98.5. And this is Q1. The interquartile range for the third one would be the middle. So this is the middle number right here, 146. And these two, that's not going to let me write up there, but it's 202 and 218. So to find Q3, 202 plus 218 equals 202 plus 218, 420, which we divide by 2, and that equals 210. And 210 is Q3. Now, to determine an outlier, I use Q1 and I subtract whatever 1.5 times the interquartile ranges to find the boundary for the lower outlier. So what does that look like? I take the interquartile range, which would be Q3, which is 210. I subtract 98.5, which is Q1, and I get 111.5, I believe. Let me just check to make sure. 210 minus 98.5. Yeah. That is the IQR. So I have to do 1.5 times 111.5. 1.5 times 111.5 is 167.25. So 98.5 minus 167.25, that equals negative 68.75, and there's no lower outliers. So that's one. I'm going to switch colors for the upper outlier because I'm running out of space here. You might have a hard time following me. So the upper outlier would be 210, which is Q3, plus the IQR, 111.5. Excuse me, 167.5. I messed that up. That's 111.5 times 1.5. 167.25. And when you add those together, what you get is 377.25. That is the upper boundary. And if we look at our data, we have one number that is above 377.25. So a 545 or $545 is an upper outlier. All right. Get that down and we will go to the next slide. Okay, underline your notes that have important information and circle your 10. Here is our assignment number 27 on pages 229 to 230. It's 6 through 8 and number 11. You can access them in our Canvas under assignments, assignment number 27. Thanks again for being here. We will see you next time.